Very good morning. Today we discuss simple equivalent circuit of for a photovoltaic cell. Last class we discussed photovoltaic cell concept. The photovoltaic cell consists of P type and P substrate N substrate. The PV is nothing but a combination of P type and N substrate. In this combinations, here the general P-type and N-type substrates are combined, they forming for barrier potential. But here, in a normal diode and PV cell, the difference is for normal diode we give the input voltage and break down the barrier potential. The current flow from source to inside of PV PN substrate. But if you come to photovoltaic cell, the barrier potential will break with the help of photons, the light rays passing on the barrier potential layer. So in this barrier potential layer, they break down this barrier potential. So they developed some amount of EMF, barrier voltage. So they break down this barrier potential and the electrons are coming out from the N substrate. So the flow of electron from PV panel to load. That's only the PV panel, that's way of working. So this is for concept. So the electrons coming from N-type substrate and this, the flow of free electron is nothing but current. So we want to do analysis with the help of equivalent circuit model. The equivalent circuit model. So the entire the PV panel is minimized into photovoltaic. The photovoltaic also we do analysis with the help of Norton's theorem. So the photovoltaic is replaced short circuit current and the anti-parallel diode. The anti-parallel diode purpose is for limiting the reverse current to predicting the reverse current flow through the panel. So this is the we want to discuss. Okay, this. So this how to minimize means if we, they're dealing for two cases. One for our panel is short circuited or open circuit. So based on that we want to do for analysis. So in this analysis, open circuit and short circuit case, we want to form some equations. Before start these two specific conditions, the short circuit and open circuit, the current flows when the terminals are shorted. When the terminals of the panel is short circuit, at that time what? When the terminals are leaves open, how much able to generate the maximum, that is open circuit voltage or Thevenin's voltage. So the diode current is, we assume there is no current flow, reverse current. So the diode reverse current is zero. So this only we want to form some mathematical equations. So that the total current is ISC minus ID. So the diode current is equal to I naught in terms of exponential of charge and diode voltage and K temperature, how much developed in this panel and minus. So this diode equations. The diode equations and this short circuit current separate we get for what is the load current. That is, so in terms of we give for graph in here. So yeah, our sun rays is, there is no sun rays that time, dark condition. So that is night time. There is no open circuit voltage. So the panel is not working. If we come to during daytime, the lighting mode, in lighting mode during daytime, the open circuit voltage and short circuit current also that this is our working conditions. So we write for open circuit voltage with the help of diode equations, diode voltage equations. We frame it and Kt into Q divided by natural logarithm of short circuit current divided by open circuit current plus and 1. So this again minimize in terms of 25 degrees Celsius. So the open circuit voltage is equal to short circuit current divided by I naught plus I1. So this we want to discuss in terms of one simple analytical problem. The problem is the IV curve for a photovoltaic cell. Consider a 100 centimeter square photovoltaic cell with reverse saturation current 10 power minus 12 ampere centimeter. Yeah. In full sun mode, it produces a short circuit current of 40 milliamps per centimeter square at 25 degree Celsius. So we want to calculate open circuit voltage at the full sun daytime and also so evening time after 3 o'clock, 4 o'clock, the sun rays is reduced. So what's the 50% of sunlight is present at that time? What is your open circuit voltage panel, how much able to generate voltage. So the first one, we want to just rewrite the reverse saturation current is in terms centimeter square. We deal for in terms of our panel size is 100 centimeter square. So the reverse saturation current first we calculate 1 into 10 power minus 10 amps, and also our short circuit current is 1 centimeter square, they going for 0.04 amps. So our panel is 100 centimeter square, so 4 amps. And our open circuit voltage formula, we will substitute ISC and I naught values, and we get for 0.627 volt. So the short circuit current is proportional to solar intensity or solar radius. So our 50% of sunlight, the sunlight is reduced to the circuit also 50%. The original short circuit is 4 amps. So the now minimize into 2 amps. So the open circuit voltage is how much? In terms of 2 divided by 10 minus 1. So 0.610 volt. So this difference is there during daytime and also evening time. Our panel is able to how much open circuit voltage was offer. So based on that, we plot the curve in the open circuit voltage and short circuit current, 2 amps and complete voltage and short circuit current. Okay, thank you.